led us through our dreams of flight, has passed by the early dreamers of our world as they watched the birds soar majestically across pristine skies. It has taken us into the realm of Da Vinci, Montgolfier, Cayley, and Lilienthal, to the sands of Kitty Hawk, and through the skies of Rickenbacker, Lindbergh, Doolittle, and Amelia Earhart. This magical road has passed through the places where aviation visionaries like Northrop, Boeing, and Douglas created commercial flying machines that ventured to the four corners of the earth. It has taken us over oceans and islands in flying boats and jumbo jets, and led us to the moon and beyond.
That sense, that dream of flight, the dream of going beyond our current environment, beyond our current reach, I think is a continuing thing for mankind.
I think there is something instinctive and very basic about humanity's curiosity and urge to go beyond any current horizon and understand something new outside.
I think where human beings can go is limited only by their imagination.
At first, the airplane was a curiosity, then a fascination, and finally, an obsession. It has taken us from flights of fancy to flights of commerce, and ultimately to flights of freedom over the war-torn skies of Europe and the Pacific during the Second World War. World War II would change the face and future of aviation forever. Once the province of dreamers, entrepreneurs, and daredevil pilots, flight was now in the hands of governments protecting their homeland. It had become clear to the scientists and engineers that to achieve substantially more speed, a new, more powerful propulsion system would be needed.
Jet age began in the late 30s when simultaneously and without the other's knowledge, two great engine geniuses, Frank Whittle in Britain and Hans von Ohain in Germany, both invented the jet engine. In Germany, of course, they kept it to themselves and were highly successful with it and produced jet fighter airplanes in substantial numbers by the end of the war.
We got into the program after the British flew their Gloucester airplane, E-2839, in May of 1941. And then they sent word to General Arnold that they had a development program which could conceivably affect the outcome of the war, and he was asked to send a technical team over to be briefed on it. And their recommendation back to Washington was that we do go ahead, cooperate with the British. So at that point, the British then turned an engine, Whittle engine, over to us, which we turned over to General Electric Company.
With the outcome of the war still hanging in the balance, secrecy was considered essential in the development and testing of jet aircraft by the Allied forces.
Part of the agreement was the imposing of very, very severe security restrictions. The British were so concerned about information leaking to the Germans that they imposed these regulations, and we had no choice but to go along with them. By the way, there probably weren't 15 people at Wright Field that even knew of the existence of this project until after the airplane flew.
In 1942, at a remote air base in the California desert, the United States' first jet aircraft, the Bell XP-59, was ready to fly. Air Force Colonel Lawrence Craigie was the first military pilot to climb into the cockpit of America's newest flying machine.
I think it's important to understand when we're talking about that first flight, it was not a normal first flight in that the propulsion system was so experimental, and Bell was, GE was a very conservative company anyway, so they, in the interest of really protecting their engine, they limited us to 50% power. So as a matter of fact, on my first flight, it took me about 2.5 miles to get off the lake there. But my lasting impression of that first flight was as we broke contact with the ground, everything was so quiet. Normally the takeoff point an airplane flight is the point of maximum vibration. The piston engine This is just the altitude.
Although no American-made jets ever saw combat during World War II, it was clear that jet aircraft technology would be the wave of the future.
Back in 42, 50 years ago, jet aviation was introduced to our Air Force, and from then on, it was a very steep curve in technology.
Over the years, the great technological advancements in aviation, the powered flight of the Wright brothers, the jet engine, all of those things were kind of breakthroughs. They were milestones in aviation which opened up an envelope, which opened up a technology, which opened up the capability for man to utilize aviation to his best interest.
The advent of the jet aircraft may have been the single most important advancement in aviation technology since the Wright brothers made their historic flight at Kitty Hawk. But these revolutionary flying machines also demanded new aeronautical designs that could maximize the speeds and altitudes that were now within their reach. At first, existing straight-winged aircraft designs were adapted for the installation of jet engines. This gave the military powerful jet fighters, like the Lockheed P-80 Shooting Star.
My first jet I ever saw, I was in Maxwell Field, Alabama, going through B-29 training. We were sitting in the classroom, and all of a sudden, an F-80 came by, and it was summertime, the windows were open. All the student officers just actually literally went out the window to watch the jets, and that was my first visual sighting of a jet. I'd heard of them before, but didn't really have a realization that such a thing could be until you saw it.
This new generation of aircraft had the potential to go higher and faster than any piston-driven airplane ever flown. But as these new flying machines came closer and closer, passing through that phenomenon called the sound barrier, they became unstable, creating sometimes fatal handling problems for their pilots.
The sound barrier was always a very big barrier to us pilots beginning in World War II in 1943, 44, and 45. We ran into the effects of the speed of sound on our airplanes in dogfights, shock waves forming on the airplanes and buffeting.
Using aerodynamic research, design, and testing information captured from Germany at the end of the war, American, British, and Soviet engineers quickly adapted their straight-wing designs to incorporate the Germans' swept-wing technology, which had been found to improve the performance of their jet aircraft.
On 1 November 1950, enemy air suddenly re-entered the war in a dangerous way. In other words, the Russian-built MiG-15s made their debut in Korea.
A few months after the Soviets surprised the world with the introduction of their swept-wing MiG-15 jet, the Americans unveiled the F-86 Sabre swept-wing jet fighter.
Tiger lead, Tiger 2 here. I got a couple of bogeys out there. One coming around at 2 level.
These two powerful flying machines would prove themselves time and time again in combat high above North Korea.
All right, there he goes. He's going down. You got him. All right, boy, that's a good deal. Watch it. We got 4 of them coming in here on 75. Hang on. All right, I'm done. Go ahead, take it. I'll cover you. All right, I'm going in now.
I remember when I got hit pretty bad in Korea. That airplane snapped so hard, and I pulled one of the tanks off of the wing. That was one of the times it was sheer terror. It's a mid-wing airplane. I got hit so hard, mine was a low wing. The whole bottom was shot out. I could look down between my legs to see the ground. And every light in that airplane that was supposed to be on went out. Every light that was supposed to be out came on. First time I had a fire warning light in the jet that didn't even faze me. I think the only reason it went out, the bulb burned out. But the engine was running. It wasn't running too smoothly. The The only time that I think I have every reason whatsoever to eject from an airplane. But there's no sense ejecting from an airplane 50 feet off the ground upside down. That would ruin your whole day too. So I didn't, and I got back.
War not only changed the direction and design of military fighting aircraft, it also had a major, although very different effect on commercial aviation.
That was the era of transocean four-engine transport airplanes, of which, in terms of land planes, I think the Lockheed Constellation was the most elegant example. And the Douglas DC-4 was the Douglas answer to Lockheed. Both of these planes were developed during World War II and originally designed back in the early 40s and conceived as passenger transports. They were in fact first put into service as military transports because of the demands of the war.
Men and wings were needed to meet a crisis in the nation's life. Many airliners joined the Army. Men and women, too, built new wings, wings for war. The Douglas DC-4 was transformed into the military C-54, which became the Air Transport Command's workhorse on the far-flung airways to combat fronts. Transport planes were carrying soldiers, 50 at a clip with full equipment. Under direct military contract, experienced airline crews flew virtually any cargo, anywhere, at any time. Men of United Airlines made over 3,000 flights across the Pacific, carried 6 million pounds of cargo to Alaska.
Very quickly, the United States emerged from the war with at least 2 production lines in full swing of transport airplanes. And the Lockheed Constellation was once described by a British aviation historian as America's secret weapon in the progress of air transport, which until the war, had the war not broken out, would probably have been dominated by German designs. The Germans had at least 3 4-engined land planes that were capable of flying the Atlantic, but the war put an end to that.
Originally put into service as the KC-97 long-range aerial tanker, the newly christened Boeing Stratocruiser joined the graceful Lockheed Constellation and the Douglas DC-4 to create a fleet of American-made commercial aircraft unmatched anywhere in the world. With an international network of long, newly paved airfields built by the military for use during the war now available to the airlines, a new era of unprecedented growth for the aviation industry was about to begin. The technological advances that had been financed by the military were now being adapted for use by the commercial aviation industry to take the traveling public to the far reaches of the earth.
As early as 1941, when the de Havilland Company in Britain was working on the design for what was to become the de Havilland Vampire jet fighter, one of the great visionary people in de Havilland said, "Do you realize that we could have all this wonderful new performance? We could have all this in a commercial airliner." And the British Comet in 1952 launched the jet age. Although when I say launched, I use the term with some reserve because the Comet had to be taken out of service after 2 years. The Comet faced something that had never been experienced before, which was metal fatigue. And the metallurgical problems of metal fatigue had hitherto only been suspected and never really known. And the Comet learnt it the hard way, and they had 2 dreadful crashes. And that put de Havilland's back to square one.
Undaunted by the failure of the British Comet, the other dreamers of commercial aviation continued to develop aircraft that would take them further and faster into the skies. In Seattle, Washington, a team of visionary engineers and test pilots were taking the dream of flight another step toward the future. In 1952, gambling an estimated $16 million, which represented almost 25% of their corporate net worth, the Boeing company made the decision to develop an aircraft that would lead them into the jet transport age.
When the jet engine came out, nobody thought of what that would produce. Nobody thought it would ever be efficient. Nobody ever thought that you could get the appropriate thrust out of it to make it a reasonable propulsive system. But look what it's done. Look what it's done to aviation travel. The jet aircraft has made the world so small. Those kinds of developments, I think, you have to do them, and the benefits are enormous.
The Boeing 707 was the most significant airplane at that time to point the direction of where commercial airliners would go. I don't think anybody would argue that particular airplane, that Dash 80, was the key airplane for the initial new ideas. Certainly done in an area of risk, putting the whole company's funds into this one airplane. That's a key word, by the way, risk. No willingness to take risk gives you an airplane no better than the last one you designed.
Designating their prototype airplane, the Dash 80, test pilot Tex Johnson and his crew first flew Boeing's newest flying machine on July 15, 1954. 3.5 years later, this watershed aircraft would go into commercial service as the Boeing 707.
In 1958, Pan American Airways and the Boeing Company really launched the jet age with the Boeing 707. And the world beat a pathway to Seattle and also to Douglas. The Douglas name and reputation had lived on, that although the Douglas DC-8 was about 1.5 years behind the Boeing, it still gave Boeing a run for its money. The introduction of the jets, which succeeded, not as many people suspect because they were much faster, but mainly because they were more economic. They were so more efficient than the old piston airplanes. See, during from 1960 to 1970, air transport worldwide quadrupled. It grew so much that the airlines literally grew out of those airplanes. And along comes Pan American once again with Boeing to launch the what became known as the jumbo jets, the Boeing 747 wide-bodied airliner.
With airlines, 747 is the biggest airplane. What's kind of neat about flying the big ones is you realize at the top of the mountain, it's all kind of the same. I was real thrilled with DC-6s. I thought DC-6s was the biggest thing I'd ever fly, and I never even dreamed that they would make such a thing as a 747.
I think if Leonardo da Vinci had seen a 747, he would have thought it quite reasonable. I think his imagination would have been so vivid and wonderful that this would have been something he could have accepted vastly more easily than anybody who could not have imagined in the 15th century flight as he did.
My father delivered mail in a horse and buggy, and he lived to see Sputnik. What a sensational time to be.
The 747 was soon followed by the McDonnell Douglas DC-10 and the Lockheed L-1011. The airline industry had made another quantum leap forward into the future. These new jetliners were bigger and more efficient, but the question still remained. Could they be made faster?
It was popularly thought that speed was what did it, and it wasn't, it was the economy. But those people who still thought it was the speed were those people who were in control of designing airplanes. And thus came the Concorde.
Alternatively, ready.
Okay, 3, 2, 1. Now.
There was this conflict that the Concorde, simply because of its traveling twice the speed of sound and getting from New York to London in less than 4 hours, that this would be an immediate success. Well, what they had not allowed for was the fact that the enormous investment, there was no way that the airplane could be sold at an economic price.
In less than a single human lifetime, technology, courage, and perseverance had taken the dreamers from rudimentary single-engine biplanes to supersonic transports that could carry passengers at twice the speed of sound. While the engineers and designers of commercial aviation were creating flying machines that could carry passengers faster and farther than ever before, there were other visionaries who were looking toward tomorrow as they developed new aircraft that would challenge another one of nature's ancient barriers. Rocket planes like the X-1 and X-15 that could go faster than the speed of sound and reach the very threshold of that unexplored world we called outer space. These revolutionary flying machines would be tested by pilots like Chuck Yeager, Pete Knight, and Scott Crossfield, men who were challenging the early missile scientists led by Wernher von Braun to determine who and what would ultimately take man into space.
He suddenly decided to get back into shape as Colin has done. So we sent him off to visit the body shop doctor.
Hallo. Ja, tuurlijk ken ik je nog. Wat? Morgen? Ik heb niks om aan te trekken. Oké, ik zie je morgen.
Weekamp 24-uurslevering. Vandaag besteld, morgen in huis.
Essential Organics vitamine C is time-released, lost geleidelijk op in het lichaam en verhoogt uw weerstand. Essential Organics, effectief als geen ander.
De gratis catalogus nu met gratis bandana. Bel 06 05 04.
Win een reis naar Abu Dhabi bij EUR7. De komende weekenden maakt u kans op een van de 3 schitterende droomreizen voor 2 personen. Gulf Air vliegt u naar een luxueus tophotel waar u een week lang vertroeteld wordt in een van de mooiste steden van het Midden-Oosten. Om deze reis te winnen moet u kijken naar de vakantiespecials van EUR7. Want EUR7 pakt flink uit met een serie speciale vakantieprogramma's vol adviezen en praktische tips. Frankrijk en Italië, de populairste vakantielanden, bijten het spits af op 11 en 12 februari. Landen van zon, wijn en cultuur. Geniet van schitterende beelden uit het verre Australië, uit Nieuw-Zeeland, Mexico en Guatemala op 18 en 19 februari. Proef de Oosterse sfeer, de tropische wilde, de mystieke cultuur van Maleisië en Sri Lanka op 25 en 26 februari. Kijk dus en laat de kans op die schitterende reizen niet aan uw neus voorbij gaan. Hoe u deze spectaculaire prijs in de wacht kunt slepen, ziet u elk weekend bij EUR7. Missen niet de vakantiespecials van EUR7 en uw kans op een fantastische reis.
Remember I said I'd once been on board his books? Well, in those days the club was exclusively football. Today
Once visited, the world above us cannot be denied. Since the beginning of time, it has been man's destiny to follow his dreams of flight and discover the magic and mystery to be found beyond the next horizon. In less than a single human lifetime, technology, courage, and perseverance had taken the dreamers from rudimentary single-engine biplanes to supersonic transports that could carry passengers at twice the speed of sound.
if you look back, the many first years of flying airplanes from the Wright brothers on, there was very little done from the first flight at Kitty Hawk up until 1947. See, we'd never been above 600 miles an hour. That's a lot of years. But then the technology made it possible for us to really take quantum leaps in advancing speeds and altitudes. And it was a matter of research, and it was all done right here at Edwards.
Edwards Air Force Base had been selected as the test site for some of the newest and fastest airplanes ever built. Along with jet-propelled aircraft, rocket-powered planes were also being tested at Edwards to learn more about the problems and solutions of supersonic flight. The Bell X-1, which was designed to be launched from the air rather than the ground, was the first rocket-driven aircraft ever to be flown in the United States.
When we got our hands on the X-1, we had a big job to do, and in that we had never flown an airplane much above 82% of the speed of sound.
On October 14, 1947, Chuck Yeager climbed into the cockpit of his Bell X-1, the glamorous Lennox. In pain after suffering 2 broken ribs when he was thrown from a horse the evening before, Yeager prepared for his 9th powered test flight in the X-1. When he was asked if he was ready to go, he responded, "Hell yes, let's get it over with."
Basically, I don't remember it as a big day because we really didn't know we were going to get above Mach 1. But we had worked our way up from 0.8 Mach number, which was as fast as the X-1 had been, on up to 8.4, 8.8, 9.4. And there we ran into a very specific problem in that we lost the elevator effectiveness of the airplane, or the ability to control it. And fortunately, Bell had built the capability into the X-1 of changing the angle of attack of the whole horizontal stabilizer, or tailplane. And by using that horizontal stabilizer, we were able to control the X-1 right on through Mach 1. Well, it took the rest of the world about 5 years to find that out, that little trick with the flying tail, and it gave us a quantum lead over the rest of the world in aerodynamics.
Another one of nature's ancient barriers had been crossed. Now the only question that remained to be answered was how fast, how high, and how far could the dreamers take their machines into that mysterious world that lay above the Earth.
When we were successful in getting above Mach 1, that opened up space to us, because from then on there was no limit as to how fast we could go.
Another experimental airplane being tested at Edwards was the Douglas-built D-558. On November 20th, 1953, test pilot Scott Crossfield took another step towards space when he flew his D-5582 to Mach 2.
The D-558 was an airplane that rather surprised all of us. Initially, it was designed to be a jet and rocket-powered ground takeoff airplane. But the X-1 air launch techniques had proved to be so useful that we decided to air launch the D-5582. It allows us to take an airplane designed for about 1.2 or 3 Mach number out to Mach 2. And that's all there is in it. You know, all the luck was riding with us when we got Mach 2 out of that opening.
The research and testing continued at Edwards as the pilots and engineers pushed their new airplanes higher and faster toward the unknown horizon. In 1957, construction began on what was to be the ultimate winged aircraft, the rocket-powered X-15.
Well, the X-15 was a natural follow-on of the research airplane program that started after World War II. It included the X-1, X-2, X-3, X-4, X-5, XF-92, and the D-558 1 and 2. And by early 1950s, we pretty much explored the transonic and low supersonic regions, and the X-15 came out of the fact that we were getting pretty confident that we could fly manned rocket airplanes. And there were engines now coming into the inventory in the early 50s with around 70,000 pounds of thrust. And it was a tremendous challenge to see if we could put that on a manned airplane and learn what we wanted to know the Mach numbers between Mach 2 and 3 and Mach 7. The X-15 was constant.
The X-15 went on to set both speed and altitude records for fixed-wing aircraft. Test pilot Pete Knight flew his X-15 to a speed of Mach 6.7, over 4,500 miles per hour. In another flight, Joseph Walker took the X-15 to an altitude of 67 miles above the Earth, proving that a winged aircraft could be flown out of the Earth's atmosphere and back.
As far as the X-15 program is concerned, and the records that I set in the X-15, those were first, and they were thrilling, they were exhilarating, they were anxious, they were scary. And if anybody tells you that those kinds of flights are not scary, they don't know what they're talking about, and they really didn't understand what they were doing.
With each new design created and built by the dreamers, the airplane had to be tested. The envelope had to be pushed. If the dreamers were to once more take their flying machines another step closer to the mystery that lay above the Earth. For many of these men and women, flying these new airplanes was not just an expression of their courage and bravery, nor was it simply the thrill of facing danger and risk. These special pilots seemed to be driven by an inexplicable need and desire to experience for themselves the exhilaration of discovering the world beyond the clouds.
Well, I wanted to be a test pilot because I felt that was the ultimate in flying. I felt that was the top of the piloting career. It was the ability to fly new airplanes, to the ability to fly airplanes for the first time. And the fun part about it was being a part of the development process, being the first one to do something with the airplane that had not been done before, putting it through its paces, if you will, demonstrating the performance of the airplane, demonstrating the stability and control of the airplane, and being able to put that down in the form of a handbook so you can pass on that knowledge.
The research airplanes were flying to learn how to design airplanes rather than prove design. We weren't proving anything, we were learning, seeing if our engineering anticipated what nature really gave us. Very often we were flying in new and unexplored regimes. It was very fascinating and interesting. It was the days before the imposer of a tremendous bureaucracy that made you carefully define the unknown before you were allowed to look at it. We used professional judgment as to calculating the risk, and we did a very incredibly good job, I think.
People have come before us, Hoger, Crossfield, those line of people are incredible contributions that they've made. If I could make just a small contribution, maybe tune just one part of a new airplane to be a little bit better, maybe make it so that somebody doesn't hurt themselves later on down the stream, or make it so that should that airplane need to be used in combat, that it's maybe just a little bit better at doing it, to give that pilot just a little bit more edge. If I could contribute just a little bit, then I'm a happy man.
While the research airplane team at Edwards was poised to go further into this new frontier, a small group of German and American scientists 2,000 miles away at the Redstone Arsenal in Huntsville, Alabama, were feverishly working on another way to take man into space. Their leader was Wernher von Braun, and he was boldly promising a journey to the moon by the end of the decade.
Went out to the Redstone Arsenal, walked into von Braun's office. The other officers said, "God, this is unbelievable." I felt like I was in Buck Rogers and Flash Gordon. There were big paintings of all kinds of concepts on the wall. You know, spaceships going to the moon, lunar bases, spaceships going to Mars, and Mars bases, the whole work, big space stations. And sure, man in space is what von Braun promoted. And he began to promote this in the early 50s. And he had, I think, an exquisite public relations sense. He said, to get support for a big space program, you go to the public. Here's a foreigner, former enemy, beginning to give speeches like none of us did, to the Rotary clubs, to the Kiwanis clubs. He began to move out.
Whereas it had not been the nature of the research airplane people to seek publicity. It was that was beneath their dignity. They were exploring the unknown, and Sunday supplement wasn't important. Well, von Braun taught us a lesson about that, didn't he?
The competition between the people at Edwards and those at Huntsville heightened, as each side became more and more convinced that they should be the ones to lead the United States into space.
We could have ridden into space on wings as opposed to a ballistic reentry or a capsule approach. But at the time, we committed ourselves to a space race, if you will. And so the fastest and most economical way to do that was with a capsule, because the capsule did not need that kind of development as a winged vehicle would have.
Problems, of course, were re-entry of the aircraft configuration at extremely high speed, and the materials problems and so forth. It was very perplexing in the terms of the technology at the time, the materials knowledge at the time. The re-entry ablative technology seemed to be the safer and more prudent way to go, although it wasn't the fighter jock way to go at all.
We thought with a research airplane program, we had a very structured program that would lead us into space with useful devices.
But it was an event that took place on the other side of the world that finally decided which flying machine, the winged rocket plane or the ballistic missile, would lift America into space. In October 1957, from the windswept plains of Kazakhstan, the Soviets launched their little traveler, Sputnik. Made of metal and wire and weighing only 185 pounds, this one small orbiting sphere would change the future of space exploration. For the first time in history, enough power had been harnessed to enable a payload to break free from the Earth's gravitational pull. And that power had been provided by a blunt-nosed, wingless ballistic missile.
When Sputnik 1 went up, I think it was sort of a wake-up call to all American technology. And you know, we had always looked at ourselves as being so preeminent in matters dealing with technology and research. But I think it was very difficult for most Americans to believe that here the Russians, the Soviets were, with their Bolshevik background and all the things that we looked at as sort of being below our standards of living and our science and our technology, and all at once here they were ahead of us.
When Sputnik went, our country was totally shook about the fact that we were second. Then they started launching dogs. Remember, they had them, we called them Mutniks after Sputnik.
It is the technology that was born on the wings of science, but one that had its beginnings in the minds and the imaginations of the dreamers. It started during the reign of Tsar Nicholas II, when a Russian schoolmaster named Konstantin Tchaikovsky dreamed of a journey to the moon. He developed a theory called reactive motion. A generation later, on the other side of the world, another imaginative young man was also dreaming of a voyage to the moon. His name was Robert Goddard. In 1926, the American scientist did in fact what Tchaikovsky had done in theory when he fired the first liquid propellant rocket into the sky. Although the flight lasted only 2.5 seconds and reached a height of 41 feet above the Earth, the technology that would carry man to the moon was born. A third great space and rocket pioneer was Hermann Oberth. His book, The Rocket into Planetary Space, further popularized concepts of space travel and rocketry. Among those who worked with Oberth was an 18-year-old student named Wernher von Braun. The future German rocket scientist was destined to become the man who would lead America to the moon.
Von Braun was, I think, a combination, a fairly unique combination of visionary, and he was certainly a visionary. We know this from his boyhood diaries and his drawings and his dreams and interviews with people who were brought up with him in Berlin. And he was certainly a crackerjack engineer. for all the grandiose plans that he had out there. Huge space stations, and, 70 men going to Mars, all these grandiose plans. As an engineer, he was extremely conservative.
It is January 31st, 1958 at the Eastern Test Range in Florida. For months, a government-appointed committee of American scientists had placed their hopes of sending the United States' first satellite into space on the Navy's Vanguard missile. But with the spectacular failures of the Vanguard, America has turned toward Huntsville, Alabama, and the Redstone Arsenal to achieve their first successful satellite launch. Today, a little over 3 months after Sputnik was sent into orbit, the United States has countered with its first successful orbital satellite, Explorer-1, which was carried into space atop the von Braun team's Jupiter-C missile.
On October 7th, 1958, 1 year and 3 days after the Russians launched Sputnik, Project Mercury was born, and America was officially in the business of sending a man into space.
The whole concept of going from manned airplane flight to manned space flight was what we were developing in Project Mercury. It was all new. We were charting new ground. We didn't really know what we were doing. We had to do it every day and develop it every day.
We were too young to really get scared of doing anything, so we welcomed the challenge. It was a lot tougher than we, of course, thought it would be.
But we were moving into space, and we were utterly naive. We were, in many cases, very lucky, but we just had the confidence to keep moving forward.
As Project Mercury got underway, production of Redstone launch vehicles began at the Marshall Space Flight Center. Careful, individual production of vehicles earmarked for Mercury from the day the first bolt came into the plant.
Well, the Mercury program, when it started, of course, everybody was concerned about the fact that it wasn't a flying machine. In fact, there's our friend Chuck Yeager used to call it the spam can, I guess, the link, we used to call it the link between monkey and man, but it didn't really require a pilot as designed.
The early Mercury and Gemini guys felt that they really didn't have too much of a role in the capsules as compared to the role they would have had flying an X-15.
In April of 1959, the United States named its first team of astronauts: Alan Shepard, John Glenn, Gus Grissom, Scott Carpenter, Wally Schirra, Gordon Cooper, and Deke Slayton. 7 men who would become the new heroes of the 20th century.
Suddenly we're famous. All of a sudden, from one day where I'm a lieutenant commander flying an F-4, and lots of people do that. Next day I'm a unique person, almost one of 7 at least, and we're suddenly well known. Well, we go out to Edwards Air Force Test Station, and we meet fellows like Scott Crossfield, who I admire very much. And Scotty almost snubbed us. He said, "Why are you guys so famous? You haven't done anything." We began to think of it. We hadn't done anything, but that's the way we were treated all those days, and as a result, we bonded much more closely than you'd expect. We 7 became brothers.
Well, I expect that most of us considered to be heroes, American heroes, and people of some accomplishments, people who are in history books. But you know, when you're sitting on the top of approximately 6 million pounds of highly explosive fuels, the last thing in your mind is being in somebody's history book.
It was early spring in the year 1961. At Cape Canaveral, the Project Mercury astronauts were making bets on who would be the first man in space. Everything was ready, a stunning array of scientific technology and raw power. On Pad 5, the Redstone rocket was waiting to go. In central Russia, Yuri Gagarin was about to shock the Americans and the world as he climbed into his space capsule. On April 12th at 9:07 a.m. Moscow time, he was hurled into space. "I looked and looked and looked, but I didn't see God," Yuri would later say. A frustrated Werner von Braun observed that when we arrive on the moon, we shall have to pass through Russian customs. Yuri Gagarin's first manned flight into space not only captured the imagination of people throughout the world, it was also a powerful stimulus to the American space program. Twice the Russians had beat the Americans into space, first with a satellite and now with the first manned flight.
We were heading then toward orbital flight. That was part of our project, and here went Gagarin around the Earth once, and then later on Titov. So it was sort of a blow to our American psyche, I guess, at that time, but we recovered well, and instead of giving up, we just went back to work and worked even harder.
It became a contest. The technology that had been born in the minds and imaginations of the dreamers was about to become real and turn the science fiction of visionaries like Jules Verne and H.G. Wells into science fact. First, there would be Yuri Gagarin's historic flight into space. Then came Freedom 7, and Alan Shepard became the first American ever to venture up from Earth and out toward the stars. Less than 30 days after Shepard's successful mission, President Kennedy surprised the world as he announced that the United States would send a man to the moon and return him safely to Earth by the end of the decade. The space race was on, and the moon was the prize.
Een hoogtepunt in de wereldgeschiedenis was de eerste mens op de maan. Een terugblik in de historie van de luchtvaart volgende week om 4 uur bij EUR7.